So what I want everybody to do is to graph e to the x in their calculator, or you can just watch me. It's probably easier that way. E to the x, e to the x. Okay, so it looks pretty exciting, right? Your typical exponential function, right? So in y2, I'm going to ask it to graph the derivative. So math, derivative, over to y1, vars, over to y1, comma x, comma x. Okay. And we're going to make this one, what? X is the variable, comma, where are you taking the derivative at? So that second x says take the derivative everywhere and plot the points. Okay. So maybe a little bit better of a window setting here. We'll make our window, oops, -5, 5, -2, 10. Okay. And we'll make that second one look different so you can see it. Oh no, you know what? We'll make it very exciting. We'll have it trace along it as it draws it. You'll see a moving circle. It'll be so exciting. Okay, so it's going to graph e to the x. There's e to the x. Okay, now it's graphing the derivative. Hey, Mr. App, it's the same thing. So e to the x's derivative is e to the x. It's the only function, or I guess it's the only non-trivial function that has a derivative that is itself. Like 0 is a function. If I graph y equals 0 and then I take its derivative, it's y prime equals 0. They look the same, but that's trivial. E to the x is the only function that when you take its derivative, you will get itself back. Cool? I think so. Okay, e to the u. Use the chain rule. E to the u times u prime. E to the u times u prime. So that's what the first half of the lesson is all about. Is can you use basically this rule. So what's the derivative of e to the 3x? Times, and then you go, okay, u is 3x, so times 3, and you're finished. Okay, you're overkilling it. So what you're saying is, Mr. App, I'll write the 3 down, I'll go times 1x to the 0, and then I'll even overkill it some more, the derivative of x is 1. So I've got 3 times 1 times 1 times 1.
No, the first part. 3. Yeah, 3x times b, and then the power of 3x plus 1.
Because it's not, okay, you need to see these two things as two different things. You need to see that this, see where the variable is? The variable is down in the base of the exponential statement. So when you take its derivative, you can use the power rule. But when the variable is up in the exponent statement, you are not allowed to do this. I will make you stand in front of the class and we will throw rotten tomatoes at you if you do this. Public shaming, I think, might be the way to go. Is that your point? Yeah, no public shaming allowed. Bad. Okay. So, y equals e to the x over 3. Well, maybe you want to write it as y equals e to the 1/3 x, just to help you out. What's the derivative? Yuck. So it's going to be e to the 1/3 x times, what's the derivative of 1/3 x? 1/3. Okay, what's the one to the left of it, down low? E to the root x. Close. How about we say u equals root x, which is x to the 1/2. So u prime equals. So it's e to the u times u prime. Does it help that we do this first? Does it help or no? A little bit? Okay, what's u on the next one? What's u prime on the next one? So, what's it going to be? So you could write it like that. Are we good or not? Give me a thumbs down if we're not good. No thumbs down. Okay, Mr. App, let's get all funky with it. This is looking like fun now. E to the sine x. U equals sine x. U prime equals cos x. So y prime is going to equal e to the sine x times cos x. Okay, what about to the right? What's u? Okay, what's u prime? Oh. Yay! Y prime equals e to the u times u prime. Would you agree that I could just do this? And by timesing by 1, you really don't need it there. So why don't you just get all excited and extend the fraction bar, and then why put it all the way over there on the right? Oh, because yesterday's rule about the derivative of arctan is 1 over 1 plus x squared. I was just really excited that somebody remembered the rule. What? You don't know that one yet? Okay, well there's 2 to remember, right? You can tell which 2 I really, oh there's 3, but there's 2 that I really stress. Arcsine and arctan. And as soon as you know arcsine and arctan, you know arccos and arccotan, right? Don't worry about secant and cosecant. Well, I'll check, but I get the feeling that arccosecant isn't very off. You know, you're out building a bridge, you need to worry about arccosecant, we'll let you worry about it then. Okay, last 2. No? What are we going to do for the one? What are we going to do here? Too far. There's a G and an H. E. Product rule! Laser sword! Equals 1. V equals e to the x. V prime equals e to the x. Okay. Put it together using the product rule. do you got? Yeah? Could you factor? What? No. Well, chapter 4 it will be. Because we'll want to do things with it, and it's much easier to work with things in factor form.
Like in the question, if it was bracket, that's bracket.
Oh, yeah. You'll have to wait till tomorrow to talk about what do you do when it looks like that. As soon as you have variables in the base and the exponent, we open a whole new kettle of fish. A kettle of fish. Can of worms. I've got my mixed metaphors. I don't know. Okay. What are you going to do for the next one? Product rule! For the first time, second plus the derivative second times the first. Yeah? Mitch. Eventually I will ask you to factor. So if you get into the habit now, you will be much better prepared for later. Can anybody generalize a formula for x to the n e to the x? Can anybody generalize a formula for x to the n e to the x? Well, everybody look at G and then look at H and say that, hey, Mr. App, they're kind of the same question. Can anybody generalize a rule? Yeah, I kind of get what you're saying. If you get y equals x to the n e to the x, its derivative will be nx to the n minus 1 e to the x plus e to the x times x to the n. What? Yes. Not that I'm going to ask you to do that, but generalizing rules are sometimes an important thing. Because then you could walk up to somebody and yell at them, what's x to the fifth e to the x? You can use that rule. It's 5x to the fourth e to the x plus e to the x, x to the fifth. Stupid, and walk away. No? Oh. Okay, graph this in your calculator. So 100 divided by bracket 1 plus e to the 3 minus x. Yeah? Got that in right? What's the window settings? They're on the next page. Oh, there they are. Window! Window! -5. 25. 120. So we graph that bad boy. So, not very many people sick, really climbs really fast, and then not many people getting sicker. It's just we got this constant level of sickness. Yes? This is all about the flu being spread. So 3 or 4 kids come into the school with the flu, and well, there's 5 kids. Looks like there's 5 kids come into the school with flu, right? Stupid kids coming to school with flu. Oh, right, they've got AP calculus. They have to come. Okay. So 5 kids sick with the flu, and then it really climbs, then it really flattens off. So we're all sick. Okay. A. B. Estimate the number of students infected with the flu. We just did that. So when x is 0, 0, we got 4.74. P of 0, we got 4 people. Well, one would hope that you wouldn't talk about 0.74 of a person, because you're being really inconsiderate. Because they're still part of people are still people too. Round up. I'm just being stupid. C. How fast was the flu spreading on after 3 days? What's fast mean? Well, derivative. The slope. So what I would like you to do is use your calculator, because we're too lazy to take the derivative. Calculator will do it for you numerically. So you can type second trace. Holy doodle. Oh, there it goes. Which one's slope? There you go. And then on day 3. Ooh, 24.99998 people. So you could say it's increasing at a rate of 25 people per day right there on the 3rd day. Should we call the interior health clinic? It's increasing at a rate of 25 people per day. Thank you. I know. But you could just do another chapter. Do another chapter. Oh. Oh, okay. And 7. And then you're done. The answer keys for all the homework. So 25 people per day. So dp dt evaluated at t equals 3, we would say 25 people per day. What's D say? Graph the derivative. When will the flu spread at its maximum? Okay, so what we can do is we get our and deriv, math, and deriv, vars over to y vars, comma x, comma x. Okay. So now it's graphing the derivative. Oh, right. What's the window setting? Oh, it's different. Window. Window. No. No. Not if I ask you to graph a derivative. Well, you can do it like we could go back and do the derivative algebraically using the quotient rule and then. But I'm just being lazy, saying. See? We can go back just a sec. What? Window. Oh, now, okay, there it is. There it is. So the second graph we just drew was the derivative. So I'm going to attempt to zoom out and draw it. Because I want to line up those graphs facing this graph. Quit picking on me. So the graph looks like that. Yes? Yeah. So when will the flu spread at its maximum? So what I want the calculator to do is to figure out the coordinates of that point. I suspect you already know the coordinates of that point. And then I want you to look at the graph of the function above and say, hey, I already know where this point is. And I want you to think about why you know it's when x is 3, y is 25, or when t is 3. You push the down arrow, it takes you onto the other one. Think about it, folks. At t equals 3, right here, you're right here on the graph. Tell me how fast I'm going, kids. People are getting sick really fast. I might not have a lot of sick people, but people are getting sick really fast. Yes? It's the steepness of the curve that we're interested in, not the y value of the curve. It's really steep there. Yeah, chemistry people, what do we call that point? Mm-hmm. Have you done titration curves yet? When you take Chem 12, you know exactly what we're talking about then. It's when the pH switches over, right? Master to base. No? Oh, okay. Sorry, I don't want to destroy chemistry by screwing it up. What? It's when the pH is climbing the fastest, though. Which is what I like to think about as calculus, right? It's just, where is it the steepest? Where is the graph the steepest? It's the steepest right there. We can ish kind of guesstimate that peak is going to be somewhere between, the peak on this curve is going to be somewhere between here and here, because it's the steepness. That's where it's the steepest. You can kind of eyeball it. Now, algebraically, I guess we can go down along the side. I didn't intend on doing this, but we can. So, quotient rule. The top is, I guess we got room over here. Top is 100. Bottom is 1 plus e to the 3 minus t. So top prime is 0. Bottom prime is e to the 3 minus t times negative 1. So if you use the quotient rule, derivative of the top times the bottom, and you're going to see why I didn't want to do this, but you're making me. All over the bottom squared. Can you see why I don't want to do this? Well, we'll finish it. We'll stop on the next line. So it cleans up really nice. If you were to graph this function, a negative Mr. Up, that'd be a positive. E to the 3 minus t over 1 plus e to the 3 minus t squared, good call. To find out where the graph is horizontal, which is, or going vertical, right? It's going really steep there. You would have to find, you would have to graph this and find its maximum. And that would give you that point right there. I'm not going to ask you to do that unless it's got a nice derivative. That derivative's a piece of smelly dog poop. Okay. Derivative, find the derivative of y equals ln x. Okay. To determine the derivative of y equals ln x, we should change it into exponential form. In other words, get rid of the logarithms. So, how do you get rid of a logarithm? Times it by a log? No. Antilog. Or, really cheesy, the word I called it in the first part of the chapter was exponentize. E to the y equals e to the ln x. What happens to e to the y? Nothing. E to the y is just e to the y. E to the ln x is x. Take the derivative implicitly, please. What's the derivative of e to the y? E to the y times y prime. Take the derivative of x. 1. Okay. change that into y prime equals. One over e to the y. Okay, I'm going to get the highlighter out. Yeah, that's a good one to use. Why don't we just do that? So the derivative of ln x is 1 over x. Cool? So the derivative of ln x is 1 over x. What's the derivative of ln u? 1 over u times u prime. And there's the other rule that you need to know for today. So 2 rules. The derivative of e to the u is e to the u times u prime. The derivative of ln u is 1 over u times u prime. Now I hope, and I know some kids have already started it, I hope that you've made a page of the rules to date to keep them together. That might be something that you would like to do. Because by making that page, it will force you to memorize them. What? And turn it into flashcards if you are so desired. Okay, what's the derivative of ln x squared? What is it? What is it? 1 over x squared times 2x. Please simplify that. 2 over x. Now, Mr. App, there's got to be another way to do this because I love my logarithms. You could also do this. I could use my exponent rule for logarithms, which is just the kitty cat climbing the Christmas tree and the star falling to the front. Remember that with the timber noises and the chainsaw and sorta? It's been a long time. Cover up the 2. What's the derivative of ln x? 1 over x. So do you get the same answer? Yes, as you cringe and go, oh, logarithms. What? No, ln e is always equal to 1. Ln e is always equal to 1. No, why does which? Because they're opposite, well, they're opposite operations. It's like, why does sine and arc sine cancel? Why do squares and square roots cancel? It's the same thing. It's 2 to the log base 2 of x. Are these bases the same? Then they can. It's exactly the same statement. Yeah. Okay, B. What are you going to do? What? 1 over 3 over x. Okay, and then what's the derivative of 3 over x? You guys don't like this, obviously. Mr. App, I don't like this, neither do I. How about doing this? Oh, good. So you could write it as 3x to the negative 1. That might be, okay, that's a good strategy doing that. So if you did that blue step, your derivative is 1 over 3x to the negative 1 times negative 3x to the negative 2. So that's one way of doing it. Cam said, Mr. App, why don't we just do this? Use your math 12. It's not kryptonite. What's the derivative of ln 3? 0, because it's a constant. What's the derivative of ln x? Minus 1 over x. And if you simplify that statement on the right, you're going to get the one on the left. I just use my logarithm rules. Division is subtraction. ln3 is a number like 1.46. What's the derivative of 1.46? Yeah. Yeah. Okay, next one. ln 3x plus 3. Mr. App, I don't want to use a log rule. That's too much work. So why don't I just go 1 over 3x plus 3 times 3. This one here is set up very nicely to clean up. Cancel the 3's, and you get y prime equals 1 over x plus 1. Okay, what's d? Times 2x. So we would write it as 2x over x squared plus 5. How are we doing? Mr. Epp, it's not so bad? Or is it so bad? I'm getting a kind of a strange look. Tess, what's bugging you? Because it's logarithms? You want me to write a little bit? Okay, if you want a little bit more detail, like I wasn't doing this here yet, but I could write u equals sine x, and then I could say u prime is cos x, so that when I use the rule at the top of my page, it's 1 over u times u prime, like you could, and then put it into the rule, 1 over sine times cos. Do you like that step? Do you like that leading step? Does that help? Oh, I'm asking folks in general. Do you like that lead in? Okay. What? Okay. And then what I blow you away with is that's cos over sine, so you could have wrote it as cotan. Yeah, so in some textbooks you'll see the derivative like this. Yeah. Yeah, correct. Yeah. That's just how I learned how to write the rule. So you want to write it that way? It's okay. So y prime, drop the 2 down out front, 1 ln x to the 1, and then do the derivative of the inside. Chain rule. What do you get? 1 over x times the derivative of x, 1. So you could write it as 2 ln x over x. Okay, what's this one? U equals x, u prime equals 1, v equals ln x, v prime equals 1 over x. U prime times v plus v prime times u. Good. I don't like you, Mr. F. ln of x. So, chain rule. U equals ln x. U prime is 1 over x. So we're going to get 1 over u times u prime. So 1 over ln x times 1 over x. Is there an I after this? There is now. Oops. See if you can do this one. ln of ln of ln of x. That's a tick. So I don't know if I like this. I don't know if I like the way I wrote that, but its derivative is y prime equals 1 over ln of x times the derivative of ln of x. Well, that's 1 over ln x times the derivative of ln x. What freaks you out as I go from that line down to that line? So you keep on drilling in until the ln's are all gone. I did leave the inside alone. Yeah, I did. That's this box. Leave the inside alone. And then take the derivative of that. That's 1 over this times the derivative. Take the derivative of that. The derivative of ln of x, yeah. I'll leave you to think about that one. Okay. So homework. You've got that assignment to do. Tomorrow, when you guys first block tomorrow? So tomorrow we will do 3.9b, and then I will give you class time to get all of the stuff done. Yeah, so we're going to do 3.9b in the morning, and then we'll use the class time to answer any homework questions you have, to work on the assignment that's due, to study for your test, to study for your retest, to sit at the back and enjoy coffee. Oh wait, you don't have time for that. But I would say sit at the back and bring your cup of coffee and get focused and ready to rock and roll. Riley. Next, I scheduled it for next Tuesday, but let's see. Right. When's that on that calendar? Well, we could move it. We can move it. I don't mind. Whatever. It's just Chapter 4 is going to start, right? So if you say, Mr. F, I'd rather do it Thursday, fine. We'll have a class discussion and we'll discuss. Greg. Welcome to grade 12. I don't know what to tell you, man. I mean we can if we can do it on Tuesday. If you're one of the few that have problems with Tuesday, then you come and talk to me about it and we work something out. How's that sound? Okay. But I don't want to be like all of a sudden it's Friday and you're asking your friends what'd you do on Tuesday and how was the test. Like that's like, do you see that puts your friends in a tough spot? They shouldn't. Yeah. Anyways, we'll leave it on Tuesday for now. Okay. So